So this is an Eclipse Pro electrical panel, and it has a number of upgrades in it. It has backflow resistors to dump any voltage coming back from the motors when they decelerate. It has an extra ground block in it because we have grounded the valves on the back. It has new state-of-the-art analog drives, servo motor drives. We've installed the proper relays for the home switches that allow the home switches to work on 24 volts, but the controller to see a 5-volt signal, which is what it's designed for. And we've rewired and consolidated some of the wiring so that we can have less wire in the cable tracks on the cutting table. The only thing that we haven't done here is upgrade the emergency stop circuit. Right now we have a basic emergency stop circuit where the emergency stop button on the machine makes a connection so that the controller sees a signal on input 2 and shuts down the process, whatever it's doing. Well, what if the computer's the problem? What if the computer's locked up? How are we going to talk to it to say shut down? There's no good way to do that in this situation. But if we add this relay in as a supervisor for the drives, and we run this relay with the emergency stop button, we can make a safer machine. So let's talk about this. Right now we have a command line, these white lines called amp enable lines, and their wires go up and to each one of the drives. So in the computer, when we issue a command, that tells the drive to turn on. Well, if we were to put this relay in here and we were to run these lines, the white amp enable lines, through this circuit, through the normally open circuits, that line would be normally broken. But if we take power from the computer and we power this relay through the emergency stop button, through a normally closed contact, not normally open, this relay would be on, allowing the normally open circuit to be closed. So when a command came down the white line, it could go through this relay and it could go to the drive, the amp enable line. All right. So computer is powering this relay on via a closed contact on this emergency stop button. That closes the normally open contacts in this relay, and we're going to put a white amp enable line from the drive on this side and a amp enable line from the computer on this side, so they can talk to each other as long as this relay's on. So to shut this relay off, the computer dies, it shuts this relay off, or you smash on this emergency stop button and it breaks the normally closed connection or opens it, and then there's no more power flow into this relay, which breaks the communication between the controller on this side and the drive on this side. So this guy becomes a supervisor of the amp enable line. So because these lines are nice and long and go over here, we can just cut them and connect them on here. And we can run power from over here to run this relay, 12 volts. There's a 12 volt power right there. And then we can take the input-2 line, so the software will still work, and we will put the input-2 line over here on one of the connections so that when this turns off, this guy sees a signal, the computer sees a signal, and the software says, oh, somebody pushed the emergency stop button. I need to know about it. And then there's one other line we need to run, and we need to run this abort line in here. The computer has the motion controller has a process running in the background that's not your application cutting the mat. It's just a housekeeping program, and it goes around and it checks all the important things, and one of those important things is the abort line. And if that sees a problem, it will shut off the system as well. So we have belt and suspenders. We have an input-2 line and an abort line controlled by this supervisor, which is controlling whether these drives can be on. And your computer and the emergency stop button. Your computer has to be on, and your emergency stop button has to be released in order for this guy to have power so that the amp enable line can be completed. So we're going to rewire this in, and then I'll be back. Okay, we've now got a better emergency stop button circuit wired into this panel via this relay as a supervisor. Okay, so let's review what we did. So previously, the enable line, the white line, ran over here, down here, and to the 2900 directly. We have now cut those lines, so the white line from each drive runs over to the emergency stop relay on these three lines. CR for control relay 1, and then point 12, 11, and 10. So this is Z, and this is Y, and this is X. That goes through the relay to the normally open side of the relay, and then the appropriate line continues from 8, 7, and 6 down to amp enable X, Y, and Z. So Z goes to 8, goes through to 12, and to the Z servo drive, and so on for Y and X. All right, now the only way this line, the white line, can be connected through this relay is if this relay is on. The only way this relay can be on is a computer has to be connected to this black box, the 2900, and powered on. That will give power to this 12 volt line. This 12 volt line goes over here and comes to the positive side, CR1-14 positive of the relay. Now that doesn't get us turned on yet. We still have to complete the negative side of the circuit. So CR1-13, which is the negative side of the circuit, now goes up over and to BIO2, and then that goes up through the cable and to a normally closed contact block on the emergency stop. As long as the emergency stop is released, this is closed, so the circuit can flow back through the cable and come back BIO1, go over here and down and connect to 0 volts where it was connected before. All right, so now this can turn on automatically as long as when you power the computer up, as long as this emergency stop button is released. If it's pressed in, the this relay cannot turn on. So you have to have it released in order for this relay to turn on. And this relay has to be on in order for the computer to, the application program, to be able to turn the drives on. And then we took off of this point here, number 9, CR1-9, there's 2 wires. One goes over here and to Input-2, so the software can still look at Input-2 to detect an emergency stop, but it also connects right here to abort, this one, so that the motion controller's root program that's running can catch an abort signal and shut things off. But simply cutting these 3 lines by turning this relay off will turn off these drives and all motion will stop. So this is the better e-stop circuit, because we're breaking a connection, not making a connection. Okay, so when we're talking about the emergency stop relay, when I say that we're breaking these lines, the white line, the communication, we're actually switching the white line from the servo drive from the controller to 0 volts. So this wire here, by default, when there's no power here on the relay, goes through to this terminal block, which is all jumped down, and then goes to this wire, which goes down and is connected to 0 volts down here. So these drives are what are amp enable high, so they must detect a voltage on this line, and if they have 0 volts on this line, then the amp is disabled. If there is 5 volts on this line coming over here from the controller, then that line is said to be high, and so this is a high amp enable servo drive. So I want to be clear that we're not just breaking this line, we're actually taking this line and connecting it to 0 volts, which is what turns or disables the drive or turns it off. All right, there we go. That's a e-stop upgrade.